Chapter E, Exercise E.105, Part A. A length of number 8 copper wire has a mass of 24.9 kilogram and a resistance of 2.061 ohm per kilometer. What's the overall resistance? Well, somehow we know the resistance per kilometer. We just need to compute the length of the wire in kilometers and then multiply that number by 2.061. But we don't know the length of the copper wire from the information provided here. We do know the mass, the radius, but not the length. Now we're going to use the mass to compute the volume of this copper wire, and then we'll assume this copper wire has a shape of a cylinder with a radius of 1.63 millimeters, and then we can compute the area of the circle, and then the volume of the copper wire divided by the area of the circle will get the length. We also need to pay attention to the units because we have millimeters here and kilometers here, and we have kilograms. First, let's look up the density of copper. I usually just use Wolfram Alpha to do a quick information search. It's 8.96 gram per cubic centimeter, and also we can just double check this copper density. This is from ScienceDirect.com, 8.96. So we're gonna just use this value, and given this density value, we can compute the volume. All right, so let's work on this. The volume is mass over density. All right, that's the volume, and the volume divided by the area of the circle, so it's going to be pi r squared. That will give you the length of the wire, and then finally the length of the wire times 2.061 ohm per kilometer. We'll get the resistance in ohm. Alright, so multiplied by 2.061 ohm per kilometer. Now we just need to make sure the units are used properly. First, the mass over density. The density over here is 8.96 gram per cubic centimeter. Right, so we need to make sure this is gram per cubic centimeter, and this is gram, so I'll just convert this kilogram to gram. So the mass is 24900 grams. Now we have the volume of this copper wire in cubic centimeters. All right, now I'm going to convert it to meters. All right, why is that? I mean, it's just we have millimeters, centimeters, kilometers, really complicated. So maybe we'll just use something in the middle, the SI unit of length, meters. All right, so we have this number. It's in cubic centimeters. Now we convert it to cubic meters. Why? Because each cubic centimeter is 0.01 meter, and 1 cubic centimeter is therefore 10 to the power of -6 cubic meters. All right, we have pi here, we have r. I'm going to convert this r to meters as well. 1 millimeter is 0.001 meters. So we have this. All right, and I want to make sure that the the parentheses are used properly. So now if you look at just this part is going to be in meters, because I have the volume in cubic meters divided by the area of the circle in square meters. Alright, so we have the length in meters, and then we're not done yet, because we have, again over here, we have the length in meters. We want to convert it to kilometers. So this is how we get the length in kilometers, and then multiply by this conversion factor 2.61 ohm per kilometer, or get the answer. Alright, it's going to be 0.686 over here. If you have a calculator, I would highly recommend you to compute this first and then write down the volume in cubic meters, and then compute this with your calculator and write down the area of the circle in square meters. Alright, and then do the division. You get the length in meters, convert it to kilometers, and then finally make the conversion.